Hi guys, I'm excited to join you all today as we begin our unit on sequences. I want you to know that a sequence is nothing more than a pattern. It can be finite or infinite, which means it can either stop or it can go on forever. But today we're just going to do a little exploratory activity on some famous sequences in the world of mathematics. So the first thing that we're going to talk about today is Pascal's triangle. Pascal's triangle is named after a man named Blaise Pascal. It's a triangular arrangement of numbers that gives the coefficients in the expansion of a binomial expression. So that's really fancy, I get it. It's named after the 17th century French mathematician Blaise Pascal, but it's far older than the 17th century. Chinese mathematicians devised a triangular representation for the coefficients in the 11th century. The triangle was further studied and popularized by Chinese mathematicians in the 13th century. And this remarkable pattern of coefficients was also studied in the 11th century by a Persian poet and astronomer. So many mathematicians contributed to this triangle. However, Blaise Pascal published it in 1665. So let me tell you a bit about this triangle. The first row is just the number 1. That comes from the coefficient of x plus y to the 0 power. Remember, anything to the 0 power is 1. That's the first term. The second row comes from x plus y to the first power. And you'll notice here that x has a coefficient of 1 and y has a coefficient of 1. So that's where you get this 1, 1 in the second row. All right, the third row comes from x plus y squared. And if you FOIL that, you'll get x squared plus 2xy plus y squared. And you'll notice that the coefficients are 1, 2, and 1. Those are the terms in the third row. Okay, so this pattern continues: x plus y cubed, quantity x plus y to the 4th power, quantity x plus y to the 5th power, and so on. And each row is comprised of the coefficients that belong to that binomial expression. That's pretty neat. The triangle displays many, many, many patterns. One of the patterns that is famous in this Pascal's triangle is called the Fibonacci sequence. This sequence is produced by adding 2 consecutive terms together to get the next term. The Fibonacci sequence was first noted by the medieval Italian mathematician Leonardo Pisano. He calls himself Fibonacci in his book that he wrote in 1202. But the Fibonacci sequence was actually one that you just did for your POD. And the last thing that I'm going to tell you before you explore, another interesting property of this Pascal triangle is that if all of the positions containing odd numbers are shaded black, and all of the positions or terms containing even numbers are shaded white, a fractal appears known as Sierpinski's triangle or Sierpinski's gadget. And this Sierpinski triangle is made of equilateral triangles. It's a recursive pattern, which we'll learn more about later on in the week, but it was actually developed by a 20th century Polish mathematician named Sierpinski. So what you're going to do is you're going to take a look at Pascal's triangle. Your objective is to analyze the triangle to determine what patterns or sequences you can find. I would love for you to be able to describe to me 3 patterns that you find on your own. And then questions 2 through 5 ask you to find specific patterns that I know exist in the triangle. So do some exploring, see what you can find. Last year's group loved this lesson. They went wild with finding patterns and sequences. Once you have exhausted all of efforts in finding new patterns and sequences, Miss Loudon is going to give you a website which will take you to kind of a rundown of all the different sequences in Pascal's triangle. And the website will tell you that there are more to be found. But it's kind of an interactive tool that allows you to explore several sequences that are known to us um, thus far in algebra. So if you have any questions, I'll be back on Friday to address them. But happy hunting, and I hope you enjoy this lesson on sequences.